is a joint effort from Andy Davidson and Will Hargrave. It's also about implications of changes in the way things happen with resource allocations. In this case, the 4-byte ASN number, AS numbers.
Hi everybody, can you hear me okay? Seems like it works. I'm Andy Davidson, this is my colleague Will Hargrave. We both represent LUNAP and I also represent NetSumo and Will represents ICL. We're just going to do a brief talk to you today and make some recommendations for practice to do with the upcoming 4-byte long AS numbers which are being assigned today and are important to your networks today. We'll look at what it means, what the motivations are, how it actually works, how you configure for them, and a flaw that we discovered late last year in the AS4 rollout to date.
So many people in this room will have AS numbers. Pretty much all of you, if you've got them, will be between the range 0 to 65535. That's the standard 2-byte AS number that we're all familiar with. Now, 4-byte ASNs, well, they mean what they say. We have a lot more ASN space to play with for future expansion.
Why are they needed? Well, we look at lots of up and to the right graphs every UK NOF and we say, well, that's good because it's up and to the right. And this is one of the graphs that's down and to the right, so therefore that's bad. The red lines are the scary ones. The vertical red line is today, and the diagonal red line, when that hits the x-axis, then that's when the internet stops growing, unless there are future actions. And the 4-byte ASN policy and techniques are the future action to keep the internet growing. So we just have these bigger numbers. We have to think about how we're going to actually write them down. And of course, the great thing about standards, you can have lots of them. So we've ended up with this huge plethora of different notation methods. All I really need to say about this is use AS plain. That RFC there basically says use AS plain, which is the big number format. The reason for this is you get all these formats with dots and colons and things like that, and when you try and actually put that in your router or router config, that messes with all your regex. Not so great. Do the RR.
Obviously you go to an RR to get your AS numbers. What's happening about assignment of new ASN numbers? Well, old days, yeah, you got your 16-bit one. As of now, at the start of this year, when you ask for an AS number, you'll get a 32-bit AS number. This might catch you out if you're not expecting it. You can still get 16-bit ASNs on request. From 2010, we entered this state called ASN locked. All existing 16-bit AS numbers from the free pool will be reserved. That means you will not be able to get a 16-bit AS number from your RAR after this date. That could be a concern.
Why is there a change? Why have we had to do some work? Well, basically it's because this is a BGP open message, probably familiar to a lot of you, and the highlighted red circle is where your AS number fits, and that's exactly 16 bits long. Someone is going to be assigned AS65536, and that does not fit into that space. It's literally too big. So the way we work is we mark the packet as a packet that's an open exchange between two new speakers by inserting the magic number AS23456 in the field for the AS number, and we put the new large AS number as a capability value inside the optional parameters. RFC 4893 implements the new capability, as I mentioned. It basically, if the capability exists, it means I am a new BGP speaker. I understand ASN 32. The new ASN is carried as a value. There's additionally a new AS4 path attribute, which is optional. That means that, obviously it's not mandatory, it means that it's only needed if you do actually speak 32-bit AS numbers, and it's transitive, which means that if you're from the old world, if you're from the 16-bit AS world, you're to pass it on, so that if 32-bit speakers that are detached will see each other's messages. AS23456 is reserved for sessions between ASN 32 speakers and ASN 16 speakers, or new BGP speakers and old BGP speakers as the RFC calls them. That's the AS number that if you only have a 16-bit capability in your router, then you'd configure the peer as AS23456 to speak to a new world network. And ASN 32 originated prefixes are in the table today. We'll look at some in a little while. The native ASN 32 BGP sessions are just normal BGP sessions. The AS path is populated with the large AS number when it's new routers talking to, or new speakers speaking to other new speakers. It's quite simple. There's nothing clever going on there, but there is something clever going on there when we invoke compatibility mode. And that is where AS333333, which is a large number, pairs with AS50000, a small number, and AS50000 doesn't have any 32-bit speaking capability. So they set up a session over AS23456, and at that point the AS4 path is injected by the AS333333 router, and the AS path is populated with these placeholder 23456 messages which represent networks in the 32-bit world. The capability mode is transitive. That means that an old world speaker can peer with another low-numbered AS and router, and the 32-bit data is elsewhere in the packet. Basically, a router that understands 32-bit AS numbers can look at the data that an old speaker is transiting to rebuild the AS4 path properly with the expanded data in it again. You'll have these bits.
So with this compatibility mode, there are a few pitfalls. I mean, chances are you're going to actually be running in this mode for some of your network in the future. You need to know what those gotchas are likely to be. If you want to obviously make a route map or policy based on an ASN in a path, then you will need to upgrade your IOSes and Cisco route software, etc., to a firmware that supports it. You could end up with a situation where maybe you've got your exchange point connection, there's a load of new members joined and they've got 4-byte AS numbers. You could end up with loads of sessions to 2, 3, 4, 5, 6. How do you tell the difference between them? A problem also could be that the best path selection gets tricked. So you have two paths, they go via different ASs, but those ASs are both 4-byte ASs, so you end up with 2, 3, 4, 5, 6 in the path, but that's actually a different route with different ASs involved. And simple things like tools as well. Most people use NetFlow for peering analysis, stuff like that. You will just get the 16-bit data exported in NetFlow, which could start to be a problem. So what about support for software? Well, it's coming. It was a bit slow previously. Now with this kind of sense of urgency, I think it's starting to become available. That's more a sort of info to check that wiki there, which gives you some will give you some useful information and can be updated as time goes on. But I mean, personally speaking, there's not a great deal of support out there at the moment, so it's slightly concerning. So on to communities. Well, we all use communities, or I hope you do. Otherwise, you've got a not very good network. The usual format, as you know, 16 bits, 16 bits. There's a new type of community proposed, so you can slot your AS number in there. Only Quagga implements this today. It's in sort of early draft status, I believe.
Okay, now I'm going to talk to you about a bug that we found late last year. I want to name check a couple of our industry colleagues who helped us with this one, because they really helped drive the research forward. Rob Shakir from GX Networks and Jonathan Oddy from Hostway assisted Will and I in actually researching this flaw. But what happened was, on December the 10th last year, a 32-bit AS196629 originated a v4 prefix, as usual. And the AS path, when we received it, looked fairly normal. The 32-bit AS number was represented by 23456, but the AS4 path had Confederation ASNs in it, which is actually illegal according to the RFC. So BGP speakers that we actually managed all tore down sessions with old world speakers when they received that path, because the standard was very, very clear, very, very unambiguous indeed on what to do when you receive an update with a community in the AS4 path, or sorry, a confederation in the AS4 path, and that RFC says you've got to tear the session down. And because it's an optional and transitive attribute that an old world speaker can't interpret and can't check for cleanness, this dirty data propagated around the internet, so anyone that had updated their software to support 32-bit ASNs at that point was losing their transit sessions. There's more analysis if you look at that message that's linked to from the slides. You can click through on the slides on the site. It'll take you to an analog post where this is looked at in lots of detail. How did it actually happen? Junos introduced AS4 support in 91R1. If you're running an autonomous system with an edge that has pre that version and post that version routers installed, then and you're using confederations, then that confederation data will leak out of any part of your edge that's running any earlier than 9.1. So if you use Junos and have confederations, you really need to go past 91R1 to stop this happening to your, or to stop your network causing this leak in the future. It wasn't just OpenBGP boxes that were doing this, because we were looking after a few OpenBGP boxes that were deployed that had the flaw on December the 10th. But earlier this year, 12.0.32s12 for the Cisco 7200 platform was released, and we single-homed it to Netsumo's network to see what happened, and basically the neighbour came up, it received the dirty update, and the session was torn down. So you could be running a 7200 with the latest build on it, and your transit sessions would simply be torn down. If you are running Cisco 7200s, or any Cisco equipment, I'd track that particular bug through your channel partners so that you know when it's safe to deploy 32-bit AS support. I do want to stress that despite this flaw, AS4 and ASN32 is not inherently bad. We actually need 32-bit AS numbers to work to support the growth of the internet. So please don't go home and write in your notes from this meeting, the message was not to upgrade. The message is to track that flaw and upgrade when the software is fixed. And the software is being fixed by all of the routing protocol software vendors. You can follow conversation about the fixing the RFC, which mandates this behaviour on the IDR at IETF mailing list.
So in conclusion, you actually probably want to upgrade your routers to software that supports AS 4-byte ASNs, whether you've got a one or not, because sooner or later we're going to start seeing a lot more of this out there. And not only that, you're going to need to upgrade your tools, train your NOC about these crazy long AS numbers that you're going to be getting in these support tickets and things like that going. Someone's going to be looking at going, it's clearly a typo. AS numbers don't have 6 digits. What are these guys on? You're going to need to lab the upgrade and do a fair bit of work on this and track that particular bug, because that could have bigger issues for you.
Any questions? Deftly silence in the room. Oh no, Rob's going to break it for us.
You mentioned NetFlow earlier. You mentioned NetFlow earlier.
Yeah.
Does NetFlow v5, v9 support a 32-bit ASN in the export?
Yes, NetFlow version 9 supports 32-bit AS numbers natively. It's there, the support is there. But your router has to run 32-bit software to know about the AS numbers and send the big number, and your collector needs to know about them. So whoever your collector vendor is, they need to have known that AS numbers can be big nowadays as well. But yeah, the version 9 standard supports 32-bit ASM.
I think the problem here is that it's you've actually, when you start really thinking about it, it's you could end up with quite a lot of things to think about in this space.
Great. Okay.
Thank you.
Thanks.